Hmm. Hello student, this is our tutorial hub, and today's topic is we just get introduced about the ideals, the important in modern algebra. So before we start, I appeal to all of you. If you have not subscribed this channel, then subscribe. If you subscribe, then you will get other videos also uploaded by me. So must subscribe. And if you like this video, then like, comment me, share with your friends. So let's start about the topic ideals. Ideals. First, we know what is the definition of ideals. First, we know what is left ideal. If we consider a ring, we consider a ring, consider a ring R and a non-empty subset subset S, which is a non-empty and subset of R. Then, if two conditions satisfies, S has to be additive subgroup of R. S has to be additive subgroup means with respect to addition, S forms a group, and the second condition is that if any element for all element R belongs to the ring R, and for all elements S belongs to subset S, we have R multiplication S belongs to the subset S. Ring always formed with addition and multiplication, always found with the binary composition addition and multiplication. So here we take the operation multiplication, the binary composition, and all the elements uh, uh, of R and S, their multiplication must belong to the S. If S satisfies these two conditions, then since R is in the left side, so S is called left ideal. S is called left ideal of R. And if just we we change the order of this, if the second condition it happens from the second, if we take the condition, if S multiplication R belongs to S, the order is now R is now on right side, then S is called right ideal. S is called right ideal of R. So what is the definition of ideal? Can be it can be that left ideal and right ideal are not found same equal. It can be, but if found equal, then we have the simple definition of ideal. So ideal definition is that if for a ring for a ring a non-empty subset for a ring R, a non-empty subset is subset of R if found left ideal as well as right ideal, then it is called simply ideal. Means here it will be that is with respect to addition forms a group and two are left ideals and R ideals will be equal. It has not equal, actually it must have the two ideas, left side ideal, left ideal and right ideal, both ideals the ring have. Then mm, S is called just simply ideal. Means for all R belongs to R and all S for all S belongs to S, we have this is the left ideal. We have we will get that left all these such kind of elements must belong to the subset S, and it implies that the left ideal um, S must be left ideal as well as the right ideal also, and S multiply R belongs to S. So here it is implies that S is also right ideal. So for any subset of a ring, if it forms a group and it is also left ideal as well as right ideal, then S is called simply ideal. S is called simply ideal. So it must have to be both ideal, left ideal and right ideal. Ideal. Some properties I wish to discuss. An example you take of ideal. For all rings, it is not found that left ideal and right ideal are equal or same. But for a commutative ring means uh, elements commute with each other. So a commutative ring, it is found that always left ideal is the right ideal. So for a commutative ring, we can say that the ideals there will be a ideal. Otherwise, mm, for other rings, there will be certainly either left ideal or right ideal. But a commutative ring, uh, all the left ideals since are right ideal, so a commutative rings have ideals are right ideals. Since it is very easy to prove also, if RS is equal to SR for a commutative ring, for a commutative ring, it is since it is equal, so this is left ideal and this is right ideal, so it must be equal or same. The S will form left ideal and right ideal both, so S is now is ideal, simply ideal. But if R is not commutative, then we cannot find RS equal to SR. This will be not be equal. Then the left ideal and the right ideal will be different. So just for a commutative ring, we will get the ideal. Another property, ideal of a ring, ideal of a ring always be a subring. Ideal of a ring, ideal of a ring always is a subring. Always forms a subring. But the converse is not true for always subring. But the converse is not true always. I'll give you an example. But the converse is not true always. Converse is not found true always. Here I am giving an example. Do this. Here we can take some subrings. We consider some subrings which are not ideals. We consider some subrings which are not ideals. Which are not ideals. So how and which kind of subrings? Let's see an example. First consider a ring of rational numbers. And this is a set of rationals. It forms a ring with respect to addition and multiplication. but it is a ring, is a ring. So its subring we can take the set of integers. The set of integers is denoted by z. So it is a proper subset of proper subset you can say also. So subset of the rationals. It forms the set of integers forms a ring also. Means it is a subring. Forms a ring means it is a subring. So what we used to know that it is a field also, ideal also. But we will give an example that it is a subring, but it is not a ideal. How? Take 2 belongs to Z. Since there is a set of integers. But if we take a set of rationals 1 by 4, 1 by 4 is a rational number, belongs to R, belongs to Q, set of rationals, then the product of these 2 multiply 1 by 4, this is the right ideal, so it will be 1 by 2, which does not belong to Z, which does not belong to the set of integers. So it is a subring, but it is not a ideal. So Z is not a ideal. So it is an example that all subring do not a ideal. I hope you like this example. You can also take set of a ring of real numbers and in the proper set the set of rational numbers, the subset set of rational numbers. You will find that set of rational numbers forms subring for the ring of real numbers, but it is not forming a ideal. You can do this your homework, just prove your own self that it is true or not. I am going another topic. We know now we know what is improper and proper ideals. Improper and proper ideals. Improper and proper ideals. If we take a ring, we take a ring, take a ring R with respect to addition and multiplication, then the ideals formed by the ring R. R is the subset of R. So the ideals and 0 is also a subset of R. It also can form a ideal. 0 is a subset of R. So these two subsets R and 0, R and 0, two ideals, the ideals R and 0, second bracket, single element there is. So 0 and R singleton set 0 and the set R, the whole set. So these ideas are called improper ideas or trivial ideas are called trivial ideas. For any set, any ring, these ideas, improper or trivial ideas, must be found. Trivial ideas for any ring, trivial or improper, improper idea. These two ideas. But if any set found that improper subset and other any set is a proper subset of R, so other any S, any ideal S is forming an ideal, any ideal other than these two ideals, R and the singleton set 0. So any other ideal is called proper ideal. These are proper ideal. You understand what is improper and proper ideal? What is unit ideal and zero ideal? What is unit ideal, unit and zero ideal? So unit ideal we know the improper ideals are is called unit ideal. It is called unit ideal and the singleton set 0 is called zero ideal. Zero ideal. So if any for any ring for any ring you cannot find out other than improper ideas. No proper ideas if a ring has for a ring if it has no proper ideal ring if it has no proper ideal no proper ideal then this then the ring or the ring is called simple ring. The ring is simple ring. It is called simple ring. Depends definition of simple ring. Simple ring. So these are some topics associated with ideals. Now I am going how a ideal, left ideal and right ideal generated by an element. Left ideal or right ideal generated by an element. Left ideal. I am first discussing left ideal generated by any element generated by an element. So how this can be? Uh, if we take a ring, consider a ring R with respect to addition and multiplication. Then we take any arbitrary element A belongs to the ring R. If A forms the left ideal, in this way we can take R A plus M A, where they are multiplication. This is addition. So this forms A actually. This belongs to this form a subset of course of the ring R. What বলছেন? So here R belongs to R and M belongs to Z. Z is set of integers. So it forms a left ideal, and this left ideal is called generated by an element A. So this is the left ideal. So it can be written in a easier form also. Just simply it will take, it can be deduced in simple form also. It in simple form it can be written A. So it is a proper subset of R and forms the left ideal, where S is R plus M, and the identity element, if R has E, then E is the identity element ME. So in this way it can be define the left ideal generated by an element. So what will be the right ideal of generated by an element? This the set A R plus EM, which is a proper subset of which is a subset of R. Uh, this set generated by these elements is called right ideal generated by E. So these are the definition of left and right ideas generated by a single element, any arbitrary element E. This is the right ideal and this is the left ideal. So the left ideal I have already discussed is also called principal left ideal, and the right ideal I have discussed, this is called the principal right ideal. So what is the definition of principal ideal? I have already discussed. Principal ideal. Principal ideal just must be left principal ideal and right principal ideal. So left principal ideal I have taken S in this way. This will be R A and M A, and the right right uh, principal ideal I have taken in this way: AR plus EM. So these are left and right principal ideas. But if both expresses same set, then it is called in this way. If it can be defined in this way, we are taking a ideal I and giving. It is defined by in this way: R A R A plus R A plus E R plus M. So important thing is to notice that for a principal ideal, the left ideal and right ideal both must be contained. Then it is called principal ideal. So this is the definition of principal ideal. And M is M I already said M belongs to set of integers. So this is the definition of principal ideal. So more things to discuss. I'll discuss later for prime ideas in our next video. And thanks for watching.